Okay, we're going to talk today about making and QCing GearMate 1000 Lite. 3 primary machines involved in that, and this is one of them, the penetrometer. I'm sure most of you are somewhat familiar with it. The grease goes into this cup, and you drop a cone into it, and the machine tells you how much the cone penetrated, and that gives your penetration result. There are 2 ways to do it, unworked and worked 60 strokes. Unworked, you simply level the grease off, stick it under and run it. Worked 60 strokes, you level the grease off, screw this cap on, and as you see there's a sort of potato masher built into this thing. That screws on top, and it goes into this machine over here to our right, called a grease worker. And basically what that does is stamps or chomps or mashes the grease 60 times, always 60 times. Then you take it back here and run it again. Doing that with it, working it like that, takes out the air, and it also tells you if you get a big difference between unworked and worked, you've got an unstable soap. So that's what that's about. We're going to move around now to the 4-ball machine. Okay, before we look at Randy running the machine, I want to talk about other quality control steps that are taken. The soap for GearMate is made in a contactor. It can be made in an open kettle, but the contactor is a newer thing. We invested in one a few years ago. And it's like a pressure cooker. And it's hot, of course. You get faster and better soap. You get a better soap faster with the contactor. And in that process, we also include this particular polymer. This is the very polymer that we use. It comes in beads like that. And that's melted into the soap to improve cohesion and adhesion, stickiness of the product. So it has to be above the melting point of the polymer for that to work, of course. So a sample is taken to the lab once the cycle is complete, and we do a soap penetration. We find out how thick is the soap, is it where we want it to be, and if it's not, we'll add oil. Now the purpose of the oil is to thin out the soap, but it also has the effect of diluting the polymer, so we add the correct percentage of polymer in with the oil to keep the polymer overall percentage the same. And pardon the noise and maybe some conversations going on, work is continuing during this process. Okay, so after we get the penetration where we want it on the soap, we do an appearance test, just a visual. We're checking whether it's smooth and shiny. And we have a visual sample that we keep in a dark closet. The QC person can just look at that and compare it with what came up from the production area. And it should be smooth and shiny like that. If it's coarse or grainy looking, it'll be milled to smooth it out. That doesn't happen too much when you make the soap in a contactor though. Okay, so we have the soap, we move it to a finishing kettle. It's brought to about 250, we drop the temperature a little bit. There we add a very high viscosity oil, graphite, moly disulfide, and a second polymer, one that melts at a slightly lower temperature that looks like this. It almost looks like flour. Same purpose. So lots of stickiness so that the product clings to the metal. At that point, we cool the batch down to where we can add the liquid additives. We don't add those at very high temperatures. And those would include liquid moly, the extreme pressure additives, rust preventatives, and a couple of other goodies. Then we take samples from the mixer back here to the lab and run a lab check on them. And 2 very important ones. And by the way, this is before the solvent is added, which is standard practice in the industry. We run the 4-ball weld point and the 4-ball wear. And if anybody wants any further information on the technical details on those, we can provide it. But before we leave today, we're going to see Randy running the test on the 4-ball weld point on GearMate 1000 at this stage of production, just as it would be normally. Okay, so if we don't pass, we'll adjust with additives. We'll go back out. Somebody will figure out what percentage extra additive needs to go in there to make this pass the weld point or the wear scar. And by the way, we expect a weld point of 800 kilograms. That means that it should pass the prior stage. It should not weld at 620. Today we're going to test it at 620. If it passes, then we know we've got at least an 800 kilogram weld point. Could even pass that. But we're going to test it at 620 because we claim an 800 kilogram weld point. At that stage, once you've passed, we add 50% of the solvent. There's a certain amount of solvent that's part of the original formula. We don't add it all at once because we might make the product too soft. So we add 50%, run a penetration, and then adjust it with the balance. The entire balance may not go in, but we adjust it to where we get the penetration we want. We're pretty close to being finished. Because this is a winter grade, we also run what's called US Steel Grease Mobility Test, and we're looking for 30 grams a minute on that as the standard. There's a separate video on that, and I can include that when we send this one off to you. And again, adjust with solvent if necessary. If the pumpability isn't good enough, we'll add a couple % more solvent. Then the batch gets its green card. Green card goes out to production. That says go ahead and fill. We have a first fill test for penetration. So as he begins to fill, after he's filled a couple of drums or whatever, he'll take a sample to the lab. They'll check that. Mid-fill, same thing. End fill, same thing. Just to make sure that everything is homogeneous. Also, we check the filter. There's a filter screen on the filling system, and it's mandatory, strictly mandatory, that you get that screen into the lab, and they will check, especially for undissolved polymer. You've seen the beads that we showed you earlier. Make sure there are none of those getting caught in the filter. If there are, then everybody back in the pool. The whole thing goes back in the mixer to heat it up again and fix it. Okay, so now we're going to look at Randy, my lovely assistant. Hi, Randy. Now, before we start, let's have a look at when this machine was calibrated. 2/19/19, and it's due again in 1920, same date. Okay, so this has been calibrated. We're going to run it at 620 kilograms. And Max, if you could show this page here. For 620 kilograms, we have to be on position 30 on the bale. That's the horizontal bar. And the weight on the bale should be, oh, pardon me, I got it wrong. 30 kilograms, right, Randy? 30 kilograms on the bale in position 20 on the bale. Okay, let's see what we got. We're in position, here you go, Max. We're in position 20. And each of these weights down below is 5 kilograms. 5, 10, 15, 20, 25, 30. So everything is as it should be. And in here, we have swimming in the lubricant, 3 lower balls that are locked in position, and 1 upper ball that rotates under load. And the test goes on for 10 seconds, and we're expecting it not to weld. We're expecting a pass. A weld would be indicated by a sudden stoppage, noise, and this handle jogging, right? So if everything stays the way it is now, we have ourselves a pass. Okay. Fire in the hole. Perfect. Perfect pass at 620. Now I will finally mention once again that the US Steel Grease Mobility Test is pretty extensively covered in a separate video, so we'll include that. And that's it, Max. Can you think of anything else, Randy? I think we're covered. Yeah, we're good. Thank you.